erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisuula eby'omulembe, science laboratory ssaako ne computer lab wamu ne bw'osomeseza omwana wo mu masomero ga Giant Schools omuli kampasi y'Ebombo Kalule n'ey'e Kabalagala toba na bweraliikirivu bwonna olw'omusingi okutambuzibwa ebyenjigiriza n'ensoma y'abayizi ey'omulembe. Mu masomero gaffe gano gonna tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuuka ku siniya ey'omukaaga nga tusomesa abaana okuviira ddala ku mutendero gwa kindergarten okutuuka ku kibiina eky'omusanvu. Tulina abasomesa abakugu mu kubangula abaana n'okubateekateeka. Ebibiina abaana mwe basomera eby'omulembe omuli buli kimu ekikwata ku ebyo bye basoma, ebisuula ebyazimbibwa obulungi, ebigazi ate nga biyonjo. Okumanya ebisingawo tukubire ku nnamba z'essimu ez'owammanga.
Combo University, a private chartered university that offers world-class education at all levels, including certificates, diplomas, bachelor's and master's degrees. Our courses include computing and IT, law, journalism, nursing, business administration, education, fashion and design, and many more. Admissions for the August 2020 intake are still open. Will you join us?
To welcome you again to today's program. My name is Mugaya Samson, as usual, and I'll be facilitating today's discussion. As usual, we are always discussing pure mathematics during this time. Last week we wound up with topic of vectors, and I hope you guys are doing a lot of practice, because that is mostly what is required of you. With mathematics, you must be active. You guys know that. There is no easy way to understanding mathematics. You have to get your hands dirty. So whenever a topic is covered, make sure you begin even digging deeper. Let your appetite, as far as mathematics is concerned, be insatiable. Do not be satisfied. Do not convince yourself that you know. The moment you convince yourself that you know, then you stop learning. There is always something new to discover in mathematics. You can always interpolate information, extrapolate information. You can always present ideas in different and better ways or in simpler ways. So there is always something to learn in mathematics. You do not settle down that now I have this formula, now I know this thing. You should always be insatiable. Do not be satisfied. Always get back down. Even things which seem like you know, you do them. You can even decide to do the same number in very many different ways, assuming you are attempting an exercise. So I hope you guys are practicing your reading that topic. I want again to introduce you to another topic. My interest is in conic sections. However, we need to get these small topics out of the way. So we want to look at Loci. Last time we briefly talked about it. Loci is plural form of locus, and locus in mathematics, it is simply meaning a path of a moving point, a path of a variable point. It's just a path. And remember we said that this path can be a curve like a circle. The point could be moving in a circle. It could be a straight line. The point could be moving in a straight line. So the path which is being described by that variable point is what we call the locus of that point. And algebraically, it is simply the set of all points which satisfy the conditions that fix the position of the point, right? Of the point P. Geometrically, it's a curve, a path, but algebraically, it's a set of points. Every line is a set. For example, if we have the line y equals to mx plus c, geometrically, that's how it will look. But algebraically, we look at it as a set. So we could say maybe this is the set of all real numbers, which such that ordered pairs now. There would be ordered pairs, x, y, such that they satisfy that condition. So when I talk about a path and then I talk about a set, do not be confused. It would be the same thing. We can look at it algebraically as a set. We can look at it geometrically as a curve. So do not be confused. Those concepts are a bit related. Now, our interest here is how we can play around with the conditions. The only skill I want you to master at this point is how you can play around with the given conditions to come up with an algebraic equation of a locus of a point. Because each of those things have equations. When you talk about a curve, there must be an equation. If you're talking about a straight line, there must be an algebraic way of defining that straight line, and so on and so forth. So here, basically, we are just going to be looking at simple manipulations, how you can find the algebraic equation of the locus of a point. What do you need to understand whatever we are going to be discussing here? If you went through O level, then you have everything you need to understand whatever we are going to be discussing here. Or if you feel like you've forgotten most of those things, then coordinate geometry will do. But we shall be picking out just a few things. For example, you need to know how to find the midpoint of a line segment when you're given the endpoints. You need to know such simple things. You need to know the equation of a straight line. If I have an equation of a straight line, can I extract the gradient? Simple things. Anyways, when we get to, we shall cross the river when we get there. I'll be reminding you that now, if two lines are perpendicular, then the product of their gradients is -1. I don't lose anything to remind you such simple things, okay? So, settle down. Now, let's get moving. To find the locus of that is you use the given conditions to find the equation relating x and y. The points must be satisfying all the given conditions. Okay, let's just dig into a few examples because I don't have, my interest is you getting the adaptability. So let's pick a few examples and then which will bring out the required concepts, and then we shall move on as necessary. Example. Find the locus of a point P xy which moves such that its distance from the point, and that is distance from the point -2, 0 is twice its distance from that point there to 0. Of course, when you're responding to a question, you need to read the question and interpret what is going on. When you're responding to a question involving Loci, look for the conditions that fix the position of the varying point. And that is the most important thing here. Look for the conditions that fix. So our variable point is moving in such a way that we have two fixed points, but every time we get the distance of this point from that point and we measure it, it is always going to be twice the distance of that point from that point. That is how it is moving. To help your mind understand this, you could use a simple sketch. You can feel free to use a simple what? A simple sketch. We can fix the point, -2, 0, this other side. You don't need to be very accurate. It's just a sketch to help your mind. The mind works better with images. it works better with images. I used to remember some statement which people used to make. Is it I hear and I remember such a percentage? I see and then I remember such and such a percentage, something like that. The mind always works well with images, so always feel free to draw some diagram to help you. So we have the point A, we could put it there, and that is negative 2, 0. And then we also have the point B, and that is the point 2, 0. Now, it moves such that the distance from the point A is twice its distance from the point B. This is simple English. It is saying the distance from A to P. To get the distance from A to P, you have to multiply the distance from B to P by 2. In other words, the longer distance is the distance from A to P. So if P is around there, x, y, then we have this distance here. And then we also have that distance there. And it has to move in such a way that if this is D, then this should be to D. If this is K, then this should be K. And this point is moving. So at some point it may be here, at some point it may be there, such that the distance from here to there, the distance from here to here is just the distance from here to here. So it will be moving like that. As it moves, it is describing some path, which we are calling the locus. And our interest is to try to find the algebraic equation of that path, which it is describing. So we know what distance is because we are talking about distance. So when we talk about distance, now the things I need you to remember is that, for example, the distance from here to here is simply the magnitude of the vector AP. And then here, also, yeah, it's the magnitude of the vector AP. So you need to know how to find the magnitude. And so we are saying now that PB or BP, whatever it may be, BP, that distance should be equal to, oh no, could begin with this one, AP. AP is twice BP. So that's the condition we are given. That's the condition we are given. So we are going to use this condition. We've already now extracted the condition. So we are going to use the condition to find the relation between y and what? Y and x. But we know AP, the vector AP. So we have magnitude of the vector AP. I don't need to go back now into all that stuff because you already know. Magnitude of the vector AP, that is square root of x plus 2 squared, and then plus y minus 0 squared. You should not be confused by now because you know that the vector AP is x minus minus 2 and then y, which is just x plus 2 and then y. And now you know the magnitude of that is x plus 2 squared and then plus y what? Plus y squared. And by the way, you can also, you may also even, if you don't love using those square roots a lot, you can also, that this is the same as saying, which means, this symbol here means, implies that the magnitude of AP squared is equal to 4 times the magnitude of BP squared. That is simply by squaring both sides. Remember, this is just a number and this is just a number. So you can square both sides and make your life really nice if you don't want to deal with square roots all the time. And so we've seen that this is x plus 2 squared plus y squared is equal to 4 times. Now BP, the magnitude of that BP. So we have the vector BP is x minus 2 and then y. That is very clear. So the magnitude, but squared, is going to be x minus 2 squared, and then plus, of course, we also have y minus 0, y squared, something like that. So here now we have an equation involving only x and y. Remember, x and y are variables. So all you need to do now is try to simplify just to have beautiful things. So you could expand x squared plus 2x plus this is 4x plus 4 plus y squared is going to be equal to 4 into x squared minus 2x minus 4x plus 4, and then plus y squared. Beautifying is simply arranging things. You take this the other side, you remain with 3x squared because we have this 4 minus that. Then you take this the other side, you will have plus 3y squared. When we come to the x's, we have negative 16, the other negative 16, the x's this side are negative 16. We take this the other side, it become negative 20. So minus 20x. I think that is all. Oh, we have constants. That is plus 16 is equal to 0. So that would be your locus. It's a beautiful curve. When we will be looking at conic sections, you'll realize you'll even be able to attach names to these kind of curves. Later on, we will see that this is actually a circle. It represents a circle. It represents a circle. And we will know why. The general concept is out, so if there are small errors here, you fix them. You fix them. It should be active. You fix them. I told you I don't love the mathematics of 1 plus 1. I don't enjoy it. I'm always interested in the general concept. In other words, when I drive the general concept home, then the lesson is successfully taught. However much you can identify like 80 mistakes on the blackboard, for as long as the concept is correct, the lesson was successfully taught. So it would be your work now to check out, hey, here it was negative 1 minus 2, we wrote this, but it's supposed to be this. That is your work now when you're down there. Pick the general concept. Okay, you can jot down that if you so wish. And we pick another example to see if there is anything new that it introduces. Again, the most important thing here is identify the conditions that fix the position of the variable point, and then use them to find the relation between the ordinates of the variable point. Okay, example, find the locus. Find the locus of a point P, X, Y. Normally we use that because we always, in the Cartesian plane, we always use X and Y to be the variables. So we try always to assume that the point is that, unless otherwise indicated. So find the locus of a point that, which moves such that, oh my God, which moves such that, its distance, from the point -3, 2 is equal to its distance equal to its distance, is equal to its distance from the line, is equal to its distance from the line x equals to 3. We want to look at that. So in our solution, you read the question and identify the conditions there. And in most cases, it is very important to begin with a simple what? Simple diagram. We have the variable point, is that. Then we have a fixed point, and then we also have a fixed line. So let us first use the Cartesian plane to see these things with a simple sketch of what is going on. The point M must be somewhere around there. You don't need to be very accurate. It is -3 and then 2. We are in x is negative, y is positive, that's all. And then we have the line x equals to 3, so it must be around there. That's the line x equals to 3. So this is our point M. So the point P moves in such a way that the distance from that point P to this point is equal to the distance from P to the line. So let us assume the point P is here. You can put it anywhere you want. Why should I put it there? Okay, this place looks a little nicer. Let me put it there. That's the point P, XY. You can put it anywhere you want. So we are being told this is the point M, that the distance from here to there must be equal to the distance from here to there. Now remember, when we are talking about the distance of a point from a line, we are actually interested in the perpendicular distance. That is, drop a perpendicular from the point to the line. And it is easy to get, it's very easy to get the distance of a point from a line when the line is vertical or when it is horizontal. It is very simple. You don't even need to quote any formula. For example, we know that this point here is the point, the x value is always 3, it is fixed, but the y value is the same as y. So that point would be that. Let's even call this the point N. So the distance of this point from that line is actually the magnitude of the vector Pn. So this distance must be equal to that. That is the information we have. With that, you now extract the condition. So we know that magnitude of the vector, this point is -3, -3, 2. -3, 2. So we get the vector M, magnitude of MP should be equal to magnitude of NP, or magnitude of NP. So you could even continue to remove the square roots then, should be equal to magnitude of NP squared. And then you continue as we did at first. So you are required to complete, dear viewer. You should be able to complete that. Once you have the condition, things flow the same way we did at first. And since you guys are proactive, I don't need to complete that. If you don't feel like completing this, then your appetite for mathematics, you need to whet your appetite for mathematics. We don't have to do everything for you. Now let us look at how you would deal with a case. Remember we said when the line is vertical, it's very easy to get the distance. When it is horizontal, it is still very easy to get the distance of a point from it. Let us look at a case where it may not necessarily be vertical. example. Find the locus of a point. Find the locus of a point which moves such that its distance from the origin is equal to its distance from the line y equals to 2x. Got its distance from the line y equals to 2x. Again, you read the question, identify the conditions, and then you can use a simple diagram to help you create an image of what you're dealing with, and then you begin the mathematics. So in our solution, now notice here that we've not been given the variable point, so you can begin by defining the variable point. That let the point be maybe p and then xy. We normally love to use xy because those are the variables we always use in the Cartesian plane. If you define the point to be alpha and beta, then we expect your equation to be an equation relating alpha and beta, if you choose to look at them as variables. But we always, the mind has already been trained to look at x and what? As variables, so it's better you use those. Now, we look at the conditions. You could use that simple diagram. This is y, and then this is x. Now we know the line y equals to x. You can even, you're free, even if you don't know how to sketch the line y equals to, you can draw it anywhere. But of course, I'm not going to do that because I know the line y equals to x passes through the origin. But even if you sketched it anywhere, this is just some simple sketch to help you understand things or to interpret things. So we could call this the line y equals to 2x, and this is the origin O. Now we need to throw in the point P. They are telling us that the point P moves in such a way that its distance from the origin is always equal to its distance from this line. So we are saying, for example, if P is around there, the point xy, then this distance here, that distance must be equal to that distance. Remember, when we are talking about distance of a point from a line, we said we are looking at the length of the perpendicular dropped from the point to the line, or the distance between the point and the projection of the point in the line. We looked at all that stuff when we were dealing with vectors. So it shouldn't be too much news to you. So now, of course, this is very obvious, the distance of the point P from the line, the distance of point P from the line. We know the line, I'm going to use the formula we derived. For example, we have, let me remind you, okay, let's just get it. Distance of P from O is going to be equal to, we know that square root of x squared plus y squared. That's the magnitude of the vector OP. Then distance of P from the line. This is going to be equal to magnitude. You remember, we said if you have the line ax plus by plus c equals to 0, and you want the distance of the point P, x naught, y naught from that line, then the distance should be magnitude of ax, it should be magnitude of x naught plus b, y naught plus c over root of a squared plus what? Plus b squared. So when we look at our line here, y equals to 2x, this line is just the same as 2x minus y plus 0 is equal to 0. If you're trying to compare it with ax plus by plus c equals to 0. So in that case, we also know that the point now, our x naught is x. I hope you're not going to get confused, okay? Let us just, we see that our a is 2, our b is -1, and then our c is 0. And so the distance is going to be 2x naught minus y naught, and then plus 0 over root of 2 squared, and then plus -1 squared. And so this is going to be 2x naught minus y naught magnitude over root of 4, that's root 5, isn't it? But now our point, these are fixed values, but our point is varying. It is the point pxy. So where there is x naught, just put x. Where there is y naught, put y. So it is just 2x minus 2y. So that would be the distance. So this would be 2x minus y over root of what? Root of 5, because we are dealing with a variable point. Then the conditions we have that root, hence we have that root of x squared plus y squared is equal to magnitude of 2x minus y over root 5. So to do away with the magnitude, we will square both sides. Is root of x squared plus y squared squared should be equal to magnitude of 2x minus y over root 5, but squared. Of course, you know you're dealing with a real number here, magnitude, and if x and y are fixed. And we know that the magnitude of -2 squared is just the same as -2 squared. The magnitude of 2 squared is just the same as 2 squared. The square, when you have a square, you may discard the absolute value sign because the square always neutralizes the negative. And so here we shall just have x squared. This means that x squared plus y squared is then going to be equal to 2x minus y squared over root 5, but squared because you squared both sides. So we could even just say over 5, which means that 5x squared plus 5y squared is going to be equal to 4x squared minus 4xy, and then plus y squared. So if you have like terms, you can collect them, which means 5 minus 4 will just leave us with x squared. 5 minus 1 will just leave us with plus 4y squared. And then this is plus 4xy is equal to 0. So that would be the locus of that guy there. Again, if there are some simple computation errors, you should be able to put that right. You should be able to put that right. Don't send me a mail saying, hey teacher, -1 and +1 is this, but you put this. Just pick the general concept, and then those small things, you correct them there. Sometimes in the studio, you don't have time to analyze everything. What's most important is you to pick the general concept. Okay. Now, let's discuss some example which may introduce another concept. Remember, as we do these examples, we're just arming you with different ways of manipulating things, but you'll get more manipulation skills as you're doing your personal practice. So after this, get the books. We always use textbooks which are at your disposal, and look for the topic and begin working out things. Because the way you learn mathematics, I will not get tired of repeating this, is by getting your hands dirty. So you should have more rough books than notebooks. You should have more rough books than notebooks. Okay. A line segment AB. A line segment AB of length 12 units. Of length 12 units. Moves freely. Moves freely with A on the x-axis and B on the y-axis. Full stop. Find the locus of the midpoint of AB. Again, when you're dealing with a question involving loss, read the question, identify the conditions. You can use a simple diagram to help you interpret or extract and use the conditions properly. So in our solution again, we shall begin with a simple diagram, but let us first define, let the midpoint be M, X, Y. So you can see here that what is mostly varying, I think, is the gradient of the line AB. If we use a simple diagram, we have that this is the line A, B, and this is the point B. Now this line is varying. At some point, it could be here. The only condition, so this would be the new position of B, and this would be the new position of A. At some other instant, it could even be around here, like that. Its gradient is varying. It could be, maybe this is another possible position of A, and this is another possible position of B. So as it is varying, even its midpoint is assuming different positions, So if we vary that line smoothly, you could see that even the midpoint is describing some smooth path. And our interest now is to try to find the equation of that path. That is what we are going to be doing. And so we have our line AB. The only condition we have is that the distance between these 2 points should always be 12 units. And then secondly, A and B must be lying on, A must be on the x-axis, Y must be on that axis. So let us assume this is X and then this is Y. We shall need a little more information. Let us assume this point is A0, because that's how a point would look on the x-axis, and then maybe this is 0b. That's how a point would look on the y-axis. So we begin now using the conditions. First of all, we are told that the magnitude of AB is 12 units. But the magnitude of AB is 12 units, which means when I square it, I should be able to get a squared plus b squared is equal to 144. We could call that equation 1. Our interest is to find the relation between x and y. That's the midpoint. Don't forget. Do not forget that. Now, how do we find the midpoint of a line? That's the next thing you should be knowing. From our coordinate geometry, if we have A as the x1, y1, and then B as x2, y2, then the midpoint of AB. If this is A and then this is B, you remember the midpoint would be given by the average of those two guys, x1 plus x2 over 2, and then y1 plus y2 over 2. You remember those things from your O-level. And so that's the same thing we are going to do. So we know also that M, x, y is going to be the point. Why am I even doing that? It's the midpoint. So we shall just say also we have that x is this plus that divided by 2. So also x is equal to a over a plus 0 over 2, which is just a over 2. And this means that a is equal to x. Then we also have that y is equal to the average of this and that. 0 plus b over 2 is equal to b over 2, which means that b is equal to 2y. So this could be 2, could be 3. So we need a relationship between x and y, and we have to use those 3 equations. So we are just going to be eliminating things. So substituting, so 2 and 3 into 1, we will have that a squared, that is 2x squared, plus 2y squared is equal to 144. And therefore, divide through by 4, you remain with x squared plus y squared equals to 36. And that's the locus of the midpoint. And you can see that is, it's a circle. It is a circle. Okay, let's look at one more example. Let me see if the time permits. Yeah, the remaining time can allow us to look at one more example. And then I'll leave you with a few questions to try out on your own. R and P are the points. R and P are the points 2, 0 and 3, 0 respectively. R and P are the points that Q, which is 0, negative Q, is a variable point. period. If the perpendicular from the origin to the line RQ, if the perpendicular from the origin to the line RQ meets PQ, if the perpendicular from the origin to the line RQ is produced. Let's use that. Is produced to meet PQ at S. Find the locus of S. Find the locus of S. This seems to be too wordy, but you don't have to fear. All you need to do is identify the conditions and use a simple diagram to help you out. And then every other thing would be as simple as whatever you feel is so simple to you. So in our solution, we can let S to be xy since it is varying. So we need a relationship between x and y. Now let's use a simple diagram. Let's use a simple diagram to see what we have, how we can interpret things. This is the y-axis, this is the x-axis. We have the point R here. And then we also have the point Q. It is 3 something, so we could put it there. This is 2, 0, and then this is 3, 0. So they lie on the axis. Then 0, negative Q. Negative Q, you can put it down here, but it's varying. The point is varying on the negative axis. I know it can even go up there, but let's just put it somewhere convenient. So that is the point Q. It's 0, negative Q. And so let me extend this line a little here. Don't need to be. So we are talking of the line RQ. This is the line RQ. We drop a perpendicular from the origin to that line. So that's that. Now we are also talking of the point. This is P. This is P. I hope. Yeah, that is P. Then we are also talking of the line PQ. That is the line PQ. And when we produce this perpendicular, it meets PQ at the point S. And that is the point which is varying. So of course, as Q varies, the position of S will also change. In other words, S is really depending on the point Q. And so we need to see that as the point Q is describing this locus, what kind of locus will S be describing? That's what we want to get. Of course, you have to use again simple things you've been doing you did in coordinate geometry. We are going to be using simple things which you guys already know. So what can we use here, or what do we know? What do we know? Now, we are talking about a perpendicular being, first of all, we have two points We have 2 points on this line, so we can get the equation of this line. We can also get the equation of this line. And then, since this is perpendicular to this, then we also know something about this line here. That is, we know that the gradient of OS times gradient of QR or RQ is equal to -1. We know that relationship between perpendicular lines, because you can see OS is perpendicular to that. So we could get that. That could kickstart us off. So what is the gradient of OS? The gradient of OS is just y over x, because this is the origin, 0, 0. I hope you are not complaining how we get gradient. So this means that y over x, implying that y over x times, so that is the gradient of OS, change in y over change in x. Then times the gradient of this. The gradient of this, we have 2 minus 0, so times 2. Oh, sorry, it is change in y. So it is 0 minus q, which is just q over, so it's 0 minus q, it's just q, and then 2 minus 0, that is over 2, is equal to -1. So remember, we are going to eliminate q. We need a relation between y and x. So what does this mean? It simply means take this the other side. We will have q being equal to -2x over y. We could call that equation 1. Call that equation 1. Because time is not on our side, time is not really on our side, I'll ask you to find the relation between now x and y using this. How are we going to find that relation? Get the equation of this line here, then substitute in for x and y, because these two must satisfy. Then use those two equations to eliminate q, and try to complete that. Required to complete, and be sure to send in your solution. This is the platform where we've always been interacting. smogaya2020@gmail.com. I'm waiting for you. I want to wish you a very nice weekend. Bye-bye.
somera mu ddiiro lyo ng'ewagiddwa Maryland High School erisangibwa Entebbe. Ssomero ly'abawala n'abalenzi tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuukira ddala ku siniya ey'omukaaga nga lisangibwa mu kifo ekiweweevu obulungi. Tulina ebisulo eby'omulembe, science laboratory ssaako ne computer lab wamu ne bw'osomeseza omwana wo mu masomero ga Giant Schools omuli kampasi y'Ebombo Kalule n'ey'e Kabalagala. Toba na bweraliikirivu bwonna olw'omusingi okutambuzibwa ebyenjigiriza n'ensoma y'abayizi ey'omulembe. Mu masomero gaffe gano gonna tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuuka ku siniya ey'omukaaga, nga tusomesa abaana okuviira ddala ku mutendero gwa kindergarten okutuuka ku kibiina eky'omusanvu. Tulina abasomesa abakugu mu kubangula abaana n'okubateekateeka. Ebibiina abaana mwe basomera eby'omulembe omuli buli kimu ekikwata ku ebyo bye basoma, ebisulo ebyazimbibwa obulungi, ebigazi ate nga biyonjo. Okumanya ebisingawo tukubire ku nnamba z'essimu ez'owammanga.